learning goal is to link this idea of direct proportion with the work we've been doing on gradient. And success criteria, you'll be able to do questions like the one I'm about to go through. Okay, so if two variables are directly proportional, now remember variables are things that can change, and variables are x and y, things we can plot on an axis system. If two variables are directly proportional, the rate of change of one variable with the other is constant. So as one changes, the other changes in the same way. The graph is a straight line. It passes through the origin. The origin is point 0, 0, and the equation is always in the form y equals m times x, where m is the gradient of the graph. And the gradient is the same as the rate of change. It's the rate of change of y with respect to x. So as x changes, y will always change in a set way. Let's look at an example. Water is poured into an empty tank at a constant rate. It takes 3 hours to fill the tank with 6,000 litres. What is the rate at which the water is poured in the tank? Okay, so if we look at part A here, the rate, now the thing that is changing is time, and the other thing is the volume, the number of litres. So which one depends on which? Well, the volume depends on time. So it's going to be something litres per something hours. So we're going to have something litres per something hours. So we have a certain number of litres per certain number of hours. So the rate equals 6,000 litres over 3 hours. Simplified, the rate should be litres per 1 hour. So we call that litres per 1 hour, we call that litres per hour. 1 hour is just hour, singular. So we've got 6,000 divided by 3, which is 2,000. So the rate is 2,000 litres per hour. And that stays constant. It stays the same. Draw a graph of V volume in litres versus time, T in hours, using this domain here. That means T goes only between 0 and 3. So we said that the volume depends on the time, so that means when we draw our axes, we will have time down here because it's independent, and we'll have the volume on the vertical axis. So it's said here to make T go between 0 and 3, so 0, 1, 2, 3. And volume, well, we use our rate, don't we? 0 litres per hour. If there's been 0 hours, 0 litres. If there's 1 hour, it'll be 2,000. So we've got 2,000 there. So first point, 2 hours, we'll have 4,000. My graph is very untidy, isn't it? 3 hours, that's 3 lots of 2,000. That's 6,000. Okay, so we've got straight line. Okay, so direct proportion gives a straight line graph. Find the gradient of your graph. Okay, so the gradient of the graph would be just like what we've done previously. Gradient is YB minus YA, or the change in Y, over XB minus XA, which is the change in X. So that's basically rise over run. Let's find two convenient points. Well, one point we know there is 0, 0, and another one, it really doesn't matter, but we found one 2000 was another point, so 1, 2000 was the second point. So we've got the points 0, 0 and the point 1, 2000. I'm going to call that one A and I'm going to call that one B. So the Y value of A and the Y value of B first on the top. So YB is 2000, Y of A is 0, and X of B is 1, and the X of A, I should say, is 0. That's 2000 over 1, which is 2000. Now it's no accident that this 2000 and that 2000 are the same, because the gradient is the same as the rate. Okay, so the gradient and the rate are the same. Alright, very important, the gradient and the rate are the same in direct proportion. Part C, we have to find the rule for V. So remember, I'll write it down here, remember that it has to be y equals mx from earlier in the video. So basically, instead of y on the vertical axis, we've got volume V, and m we just calculated is 2000. Right, so we don't have y, instead we have v. M we just calculated that, that's 2000, and instead of x we have time, which is t. So v equals 2000 times t, or v equals 2000 t is the rule. In part D, use the rule to find the volume after 1.5 hours. So that means t equals 1.5. So basically v equals 2000 times t. Now t in this case is 1.5. So that's 3,000 litres. Find the time to fill 5,000 litres. So part 2. So we're given volume, so we've got the rule V equals 2000 T. We're given that volume is 5,000. 5,000 is 2,000 times T. Now we have to solve to find T. So that means we need to divide both sides by 2,000. We need to do the same to both sides. It's a one-step equation. So if you're going to use a flowchart, it would just have two sets of squares there, or rectangles. Okay, so that would be changing the sides. That would be t is 5 over 2, or 2.5, and time is in hours. So 2.5 hours. So that's direct proportion, and hopefully you can link that with gradient.